All right, hello out there. We're going to be taking a look at graphing functions and their derivatives. It's going to be a three-part series. The reason being is that sometimes we're given the actual function and we're asked to make inferences about the first derivative or the second derivative. We might be given the first derivative and asked to make inferences about the actual function or its second derivative. Or we might lastly be given the second derivative and be required to work backwards and make inferences both about the first derivative and the actual function. So we're going to start here with this function right here. I just labeled it f of x, and first thing we should be able to do is just understand that the derivative is the slope at any given point. So for example, if I was to look at this point right here, well obviously this function is decreasing, so it has a negative slope if I was to graph the derivative. And also, the other main thing we need to be concerned about is that any minimum or maximum contained on the actual function is going to be a zero of the derivative. So, taking a look at our function, I can easily spot two extrema. We have a minimum right here. We have a maximum right there. Also, remember they are relative. They're definitely not global minimums and maximums because the function increases towards infinity and obviously decreases towards negative infinity right there. So, because this is a minimum, its slope is obviously 0. We could draw a tangent line that has a slope of 0. And because of that, if I was to go down and graph it here, we know there's going to be a 0 right there. The same thing can be said for this maximum. If I was to go down to f prime of x and graph it, there's going to be another 0 right there. Now, because this graph, f of x, is decreasing, we talked about how that is why there needs to be a negative slope in the actual derivative. So that's why on this side I'm going to be coming up. Then notice the function between -2 and 0 is increasing. It has a positive slope. That's why it's going to go above the x-axis before coming back down and touching that point right there. And then notice from that point it's decreasing, and that's why it's going to have a negative slope. So one thing we can spot as well, it does appear that the actual function is a third-degree polynomial, while this one right here is just a quadratic. All right. Also, it's important to notice that we can make some inferences about the second derivative. Now, we could just take the first derivative and graph its derivative, and that would give us a fine and dandy second derivative. However, on the calculus test, if we were given the actual function and we want to graph the second derivative, we can actually just skip this process and probably be able to identify multiple choice answers just based on the fact that this function, since this section is concave up, the second derivative is going to have to be positive wherever it's concave up. So we know that around here it's going to be positive, and then there's these things called points of inflection that if you look at the original function, which is the one we've been given, whenever there's a straight line or something approximating a close line, there's going to be a point of inflection right around in the middle. So in this graph, it does appear that it's happening at x equals -1. So if I go down to the second derivative all the way, that's where there would be a 0 on the second derivative. All right, we don't need to graph the entirety of it, but keep in mind, like I said, if this is the function, this is definitely concave up right until that point right there. Since it's concave up, it's going to be going in a positive direction. And then from here on, it's definitely concave down, so it's going to be decreasing. And notice once again, the way it works out is each time the derivative decreases by a degree of 1. We have a third degree, we have a quadratic, a second degree, and then finally we have a linear function. So, that's pretty much what you need to understand right now. We're just covering the basics of functions and derivatives. In the next section, I'm going to show you how to, if you're given the derivative, work backwards and talk about the actual function, and also make some inferences about the second derivative. Alrighty then.